Hi everybody, we got a lovely question here. The circumradius of a triangle whose sides are given to be as 13, 12 and 5 should be one of these choices, and we are expected to find it out. Now, there are a lot of technical details involved in this particular question, though it looks simple, but there is a level of technicality that ought to be understood by the individual who is willing or wishes to solve this question. Foremost, it is talking about circumradius. Okay, we have already come across terms like circumcenter, but what is circumradius? So to understand circumradius, we need to know what is actually a circumcircle. Now imagine you have a triangle like this, and there is a circle which is hitting all the vertices of the triangle. You got the vertex here A, this is B, this is C, and you have a circle which is hitting all the vertices. Now circumradius is nothing but the line segment that joins a vertex to the center. They want us to find this length. It can also be this length. It can also be this length. So they are asking us to find the length of OA. That is the simplest way to understand what exactly is required. So we are going to find this out. Now, in this particular illustration, I will also explain to you what is the meaning of excenter and incenter. See, these are also two technical terminologies which will come in the picture whenever we are dealing with competitive questions or questions which are of high intensity nature. So I will also make sure that I'm explaining these two important concepts, excenter and incenter. But foremost, let me just solve this question. So we are expected to find the circumradius. So as I mentioned to you, it is nothing but, I'm talking about the circumradius. It is the line segment that connects the vertex, any vertex of a triangle, to the circumcenter. So when you're talking about circumcenter, we're talking about the center that is present here, and that center is shared both by the triangle as well as the circle. Now this is a formula. So that formula, so this is nothing but the circumradius, and this circumradius is given by the formula ABC divided by square root of A plus B plus C multiplied with B plus C minus A multiplied with A plus C multiplied followed by minus B times A plus B minus C. So clearly you can see that A plus B plus C is the leading term, whereas the other terms have got alternative minus signs to be featured as a prefix to their terms. So this is the formula that we will be using. I'm going to be taking the values given by the question 13, 12, 5. So if I were to take A is equal to 13 and B is equal to 12 and C is equal to 5, then this formula can be rewritten as 13 into 12 into 5 divided by root of 13 added with 12, that's going to be 25, added with 5, that's going to be 30, times 12 added with 5, that's going to be 17, minus A, that's going to give me 4, times A added with C, that's going to be 18, minus B, that's going to be 6, and then A added with B, that's going to be 25, minus C, that's going to be 20. So this is what we have got. So this is equal to, I'm not going to multiply the terms, so let me retain it as they are. Now 20 into 30, that is 600, times 4, 6 4s are 24, times 6 4s are 24, 2 6 2s are 12, 13, 14. So you got 14400, and you have to find the square root of this term. So let me write that down, 14400. This can be rewritten as, if you don't have a calculator, then this is the best way to rewrite. So it's going to be 144 multiplied with so many number of zeros, right? So this can be further rewritten as 13 times 12 into 5 divided by root of 144 times root of 100. So this is equal to 13 into 12 into 5 divided by 120. This is what we have got. 12 times 5 is 60 multiplied with 13. 6 3s are 18, 1 6 1 6 7, 780. So you got 780 divided by 120. So clearly you can cancel the zeros here. 0 0 can be cancelled, and you got 78 over 12. And probably you can reduce it by 2. 2 divides 12, 6 times 2 divides here 6, 39. So you have a quantity of 39 over 6. 3 divides here 2 times, 3 divides 1 time, and 3 divides 9 3 times. So you have 13 over 2. This is my value for R, and that's the solution for this question. Now, as I mentioned to you that I will be explaining to you what is called as the incenter and the excenter. Now let me start off with the incenter. This is a very important property. So let BI and CI be the angle bisector. I would say internal angle bisector of angle ABC and angle ACB. So if I were to draw the figure would be of this nature. So you got A here, you got B here, you got C here, and you got I there. So I is hitting here, this is I, and then there is hit at this vertex also. So CI and BI are angle bisectors. So definitely these angles are going to be divided into equal parts, and this is also going to be divided into equal parts. Now this I is what is called as the incenter, and the angle BIC is the incenter, and that is given by 90 degree positive. This vertex is A, right? So it's 90 degree positive A over 2. So that is the incenter. In other words, angle BIC is 90 degree positive A over 2. Now later on we will do some questions involving that. Now coming to the excenter, let me define the excenter. Now if BE and CE are the external angle bisector of angle ABC and angle ACB, then the excenter, let me show the excenter to you. So this is the usual triangle, but this is A, this is B, this is C. Instead of we dealing with the internal angles, we are now dealing with the external angle. So we take a point E here. So there is a bisector that is dividing the external angle into equal parts. So this and this will be same. Now similarly, there is, if only I could have little bit, okay, never mind, let me adjust and complete the figure. So there is a division that is happening here, and this angle and this angle are going to be equal. Now this part is called the excenter, right? Probably you can extend this little bit. This part E is the excenter, and this as an angle. Now this angle BEC is given as 90 degree minus angle BAC divided by 2. So this is also rewritten as 90 degree negative A over 2. So this is the excenter. In the incenter it was positive, but the excenter it's negative. So remember the excenter and the incenter and the angles that are being represented here. So we will come back to this concept later on. Since I have done the question related to the triangle and the circumcenter, I thought I should mention the incenter as well as the excenter as a side note. Thank you everybody.